ArcGIS, yes. I mean, let's get psyched up here. Yeah, I just went and bought my lunch and I said, hey, we're number one. I'm not sure what it is, but hey, that's what we are. Whatever you say, you should just be number one. Then I saw a T-shirt and the guy said, prepare to die. Come on. Then on the back he had prepare to live. But anyway, I thought maybe you should. I asked him if he put the T-shirt on back to front. Okay, so we are going to have this lesson. It's a brick. This brick. So you probably don't want to deal with this in paper form. It's 70 pages long. There's a PDF document there, and it's probably just as easy just to follow that through and not have to worry about messing around with paper. It has these links, and the links work, so you can go to different parts of the document and see different sections. You don't have to access it just as a single document. And so we'll just follow through on the digital version of this document. There's an exercise assignment for this in Canvas, which you'll submit your results to Canvas. I sent out a notification, well, the university sent out a notification inviting you to join the ArcGIS Online account. If you've not received that invitation, please let me know. If you just got added to the class, maybe you didn't get it. And then they made a mistake when they sent out the invitation, because they should also have authorized you to access ArcGIS Pro. So at first that didn't work. It's a separate thing to inviting you to be on the organizational account and to authorize you to use ArcGIS Pro, but they fixed that, and so everything should be working. Is that true? Have you been able to work with the software? Okay, lots of nodding heads. Yep. Everybody's responded to their invitations. Yes. No? Yes. Well, if you haven't done it, please respond to the invitation, because you cannot do the homework without having done that. Doesn't matter how you use the software, you've got to be a member of the ArcGIS Online organizational account. Dr. Talbot, before we get started, are there any thoughts you have? I mean...
I think we're just excited to see this introduction to ArcGIS Pro.
Yeah. Well, I had a lot of fun going through this, teaching myself some things that I wasn't as sure about as I am now, and Dr. Tarberton helped, and he taught this class last year because I was involved with Harvey, so some of what you see was actually a product of what he did as well, so that we'll switch back and forth from time to time in commenting on things. So just to start off, what are we trying to do here? This exercise introduces you to ArcGIS Pro. You're going to create a map and you're going to create a chart. You're going to show how the map and the chart are connected together, and then you're also going to answer some questions about the data that are in the map. These are pen evaporation stations at different locations in Texas. I'm going to be turned in. So at the end of the exercise, there's a set of items, which there are 5 of them, to be turned in. And some of these are just pretty straightforward questions that are involving interpretation of the data that's there. Some of them, like prepare a chart, for example. This one, prepare an ArcMap layout, is the largest to be turned in item. And the last part of it is to prepare a web map so that you can actually show other people on the web what your map looks like. And, for example, and store it in ArcGIS Online, and then you can publish your map. And this is my map here. So at the end of this, you're supposed to end up with a map that looks like this, that is made public and other people can see it, and I can see it. So what I want you to do is to take all the responses to all these items, and I like them in PDF format. Dr. Tarberton says Word or PDF. I like PDF, and particularly because I've got a lot of students to deal with. I don't want to mess around with Word files, so please do not submit homework as Word files. Take all the responses that you're asked for here, put them in a narrative document in a sequence in Word if you want, and then convert it to PDF and submit the PDF document to Canvas. That's how I like to get them. It doesn't really matter what you call the document, because Canvas sorts it out and assigns it to you, and that it works fine that way. So this is due a week from today, midnight a week from today. So there's plenty of time. If you have questions, you can ask them in class on Tuesday, and we'd be happy to answer them. Okay, so what are the computer and data requirements? You need ArcGIS Pro version 2.2. There's some things that are in 2.2 that weren't in earlier versions, not very large things, but a few. And the data is accessed here. So if you just click on this link, then you'll find the data will just show up, and I'll show you what they look like. I've also linked that to the course webpage separately. So the data are actually comprising three shape files for Texas called counties, evaporation, and a state border called Texas. And if you look at it, so here's what the data looks like. So, oh, look at that. There's some additional things here. You probably don't need these lock files here, so let me just get rid of them. Lock files are created when you open a data set in an application, so probably there's some residual there, but anyway, it doesn't really matter. So these are shape files. You don't need to know what they look like. This Texas.shape here is where the geographic coordinates are stored. You can see that's rather a larger size than the other. And Texas.dbf is where the attribute tables are stored. And these other ones, the PRJ is where the geographic projection coordinates are stored. I don't even know what's in some of these other files. I don't know and I don't care. And you can see these are repeated. Evaporation has a similar set of files as what Texas does, and counties has another set. And you don't need to know how the information is stored in any of these files. It's a bit inconvenient. There's a big pile of them. That's why there's a zip file for you to look at. But we'll fix that by storing the data in a geodatabase. So you download the data, you get the files in a folder, and then just unzip them, and it doesn't really matter how you do that, and just put them somewhere where you're going to work it. Okay, so now we're going to start ArcGIS Pro. So we always start this class by saying start ArcGIS Pro or start ArcGIS. For whom is this the first time? Nobody. Everybody's used ArcGIS before. No, yeah, come on. Yeah, this is great. I mean, I always say we start with ArcGIS Pro. We don't make any assumptions that you've done all this work before. And many of you I know have done GIS before, probably using ArcMap. So even if you've done ArcGIS before, perhaps not with the Pro version. Now I'm already signed in here, so I'm going to sign out just to show. When you sign out, it says ArcGIS Pro is not connected to a licensing portal and will close in 60 minutes. So when you first log in, you'll have to sign in. So I'm just going to say sign in, and I've put some instructions when you authorize your software. I think you should use this enterprise logins route, because that associates you with UT Austin. But once you've done that, you don't need to bother with that again. So you can just say login, or if you're on a computer that's in the lab where it's already registered as part of the ArcGIS Pro organizational account, then it's fine. And then we're back in. So we're going to start off with having a blank project. And so you just say blank, and here you navigate to a folder that's going to be the place where you're going to do your work for the project. So I'm going to go back to where I've established a file set for this class, which is on the C drive under GISWR 18, session 3, EX1, and I'm going to call this EX1 demo. This is just the folder. So I established this EX1 demo folder just before class. So this is your workspace. So you set this up so that when you get to this point, you've got a workspace to navigate to, and I'm going to call this EX1 project. Okay, so now when you look inside of your Windows Explorer, and you come to EX1 demo, there's this thing called EX1 project that got created in there. And when you look inside of that, you've got this thing that says EX1 project toolbox. That's for models and functions. EX1 project. This is called a .aprx file, and this is where you keep storing the current content of your project, keep registering it. I'll show how to do that in a minute, and here's where the project Geodatabase is. So this EX1 this EX1 project folder here contains everything for your project once you get it going. Okay, so now we've opened up a project and we've got a space for it to do the work in. We're going to make a new map. So when you first open up the ArcGIS Pro, it's sort of confusing. I think so anyway. You can see there's a thing in the middle here that says toolboxes, databases, folders. I don't know. I don't even understand that. But anyway, the way to get started here is to go to Insert and then say New Map. And when you do that, that middle panel gets replaced by a map. And you go, oh, okay, now I see what I'm doing here. So the left-hand side is called the legend, the map legend, and it's going to contain an index of all the data that we display. And the right-hand side is where we've got functions and data information that we want to look at. So this is a catalog, and here we've got databases, and we've got this thing EX1 project.gdb, which doesn't have anything in it right now, so it's just blank, just a holder here. There's also something here for Symbology, which again is blank, but we'll get to it in a short time. So let's see. Okay, so we've got a map of the United States. This is actually this is a topographic map. There's other formats that you'll see as we go along. Now we're going to add some data to the map. So if we come here and say add data, you'll see there's lots of different ways that you can add data, and we'll go through some other mechanisms of that as we go further along in the class. But in this instance, we're just going to add the data that came from the zip file. So just use your normal navigating system to navigate to the place where you put the data. In this case, I put it in this one called EX1 data. And we're just going to take each of these, and if you press Shift and just click on the files, then they all get added at once instead of having to add them one by one. So we've got the files added, and you'll see that they're in the order Texas, Counties, Evap. Now both the Counties file and the Texas file are polygon files, and the Texas file is below the Counties, so you can actually see the counties. If we were to drag the Texas file above that, whoops, counties all disappear, which is a bit depressing. So we've got our pan evaporation stations here that you can see in these purple dots. These colors are randomly assigned. There's no consistency to that I can see, although maybe internally they're connected, but we want to assign new colors to make the display easier to read. So now we've added the data. We've got some data here. You can see when I did it in preparing for the class, it all came out in greens. Now we're going to take our project and we're going to say project save. So save your project and save it frequently. There used to be something in Windows machines called the blue screen of death. I don't know if you've seen the blue screen of death. Well, yesterday and this morning I saw the blue screen of death twice. And sometimes when you do graphic...
I haven't seen it in ages.
Yes, so Dr. Talberton is a more powerful computer guru than I am. Maybe his computer is better than mine. Probably that's the truth.
You must be living dangerously.
Yeah, and sometimes, particularly when you're changing the symbology, it's something to do with graphics display. Just suddenly, poof, and you get this face on the screen going, this is, I'm feeling bad. And you've got the blue screen of death, and you have to totally restart the computer and start all over again. So frequently save your project and frequently save any work that you've done for the homework. Yes?
Is there like an autosave option that you could...
That's a good question. No, I don't think there is. Like on Word, there's autosave. Yeah. No, there's not. I don't see there's any autosave here. So you're the autosave, right? Yeah, it's you. Just keep on saying project save. Okay, so we've got our data displayed. We've saved the project, and if you want to restart the project again, if you have a crash, if you go back to where the project is stored, EX1 project, and then just click on this one, EX1 project, it'll restart the whole of ArcGIS and it'll open up the project at the place where you were when you last saved it. And you don't start the project, don't start ArcGIS Pro from over here on the start menu. You start it from this file, which is the project file that contains the display of the equipment. And you'll see the screen opens up like this. Okay, so
I've just checked in Google,
ah,
and there is help information on setting up autosave.
So for ArcGIS
So-
there's a help?
ArcGIS, so if you Google ArcGIS Pro autosave, you'll see instructions.
Okay, there we go. I stand corrected.
Will you leave it at that?
Yes, so if you, Google ArcGIS Pro autosave. Probably I should do that, and, well, we haven't got it prepared here yet, so I'll take that as a note for the future. So we've got our counties here that in this case are blue and the points are in green, the Texas is underneath. We want to take the Texas and we want to be able to modify this so that it's just an outline. It doesn't have any interior content because there's really nothing to be seen there. So if we take our Texas file and just click on this color thing here, you'll see now the Symbology panel opens up and you've got a number of choices. If we go, this is called a gallery here, and this is properties. So if we go to properties, and we have color here and fill color and outline color and outline width. So if we go to color and say no color, to outline color and say green because we're very green, and we say 2 points in width, and then we say apply. Oh, bingo, look at that. That's kind of nice. Now we've got a nice little background line that's around Texas instead of having this big muddy thing in the middle. And we've got an outline for the state. And again, let's just save the project so that it'll preserve that for us. Won't have to do it again. So another way that you can get to an outline is just to click on, when you're in the gallery, just to click on one of these things that says outline and change the color. So there's a couple of different ways that you can make an outline. Clicking on the left arrow and the symbol toggles back. What's this? You put in this, David. What's the
So, I mean, if for example, you went and open the Symbology from the right click on the layer, you would end up at a higher level in this hierarchy. So just go into ArcGIS and click on that, and you'll see you get the view at the left.
Okay.
So click on text, right click on that and go to Symbology. No, click on the word text that's up above and do Symbology. Then you end up with this sort of look. And then if you click on symbol, you'll get back to where you can edit the things.
Okay. Very
And
good.
then if you click on the arrow back at the top, you'll get back to that other mode. So just pointing out that there are two modes that you can end up in, and sometimes it's confusing, so it's useful just to experiment a little bit back and forth to orient yourselves as to how to work in.
Okay, so that's a very good point. Thank you, Dr. Tarleton. There's always little tricks and twists in these things. I usually do this method, which is kind of the longhand method of getting to Symbology. I do it this way. So I've been accustomed to coming to this version, but the quickie way of doing it is just to do this as we did, in which case we come to this gallery and then do the property. So there's a couple of different ways, the quickie way and the more sort of formal way of getting at the Symbology. Thank you for bringing that in, Dr. Tarleton. Dr. Tarleton is big on these red boxes, so everywhere you see a red box, he's the one that put the red boxes in there.
Well, that's to show you where you have to focus on the...
Yeah. I'm kind of like, I like a highlighter, you know, I'm not too much into red boxes, but hey.
Well, maybe I should make them green or blue or some more passive color.
Yeah. I wrote a book with Esri Press called ArcHydro-GIS for Water Resources, and the book was reviewed by a cartographer, an Esri cartographer, and she hated red. And so every time she saw red and then she stippled it out. She made very thin lines, you know. Red is very aggressive, apparently. Okay. So we've got as far as
Luckily I
that.
got my blue shirt on today.
Yeah. Oh, there you go. You got a blue shirt. You're good. Okay. So
And red is the University of Utah colors. So
is that right?
that one
Well,
is
okay.
different.
There you go. So similarly, we're going to color in the counties here in some kind of nice light green color, just so that it's a little bit shows up better. And you'll see that when you do that, the outline in this gray kind of disappears. So change this to something darker. Say apply. And now you can see the counties of Texas. And you've also got the points that we can still see them fairly clearly. When I did this and preparing for this, my points were green and they all just kind of blanked out when I got to this point. So what I did was just change the color of the points to red. So just to be consistent with what we've got in the exercise, let's just change these to red. So we've got our basic layout now of our data in some sort of a useful form. And this is really the first step in the exercise, which is just to take some data and make a map. So there we are. You've made a first, when you do this, you'll have made your first map. You're supposed to go, yeah, this is really cool that I've succeeded in doing this. That is kind of cool, actually. Yeah. Okay, so once we've got to this point, let's see, this is the toggle back and forth thing here, is that right? Yeah, that's right. No, sorry. So this is another thing that Dr. Taberton put in. So you've got two boxes at the bottom here. You've got the catalog box and you've got the symbology box. So apparently you can take this thing and drag it. Oh, look at that. Isn't that cool? You can drag this out. So you can actually look at the symbology and you can look at the catalog at the same time. And if we look at the catalog and look into our project Geodatabase now, seems like we should be able to see. Oh no, we haven't got it. See, we still don't have anything in there because I haven't put the data in there yet. So what do I do here? I just drag this down the bottom again, or?
Well, you hover your mouse over the middle part of the, see the orange things that pop up when you drag back to the right?
Whoa, that's bad.
Minimize
Okay.
that. So drag it. Now you'll see the controls pop up. So now you can select on those controls. You can choose where to drop it. So you have to drag it down and make your mouse go onto one of those things.
Okay, so what do I do? Just put it like this, huh?
Well, that'll drop it on the side of it.
That wasn't a good idea. Let me try it again.
So drag it, try it again, and now drop it on the middle of it.
Ooh, cool. Okay, there you go. I didn't know that. So that's, I've always just done it by clicking back and forth between these two tabs down here, but you can open these up as separate draggable windows as Dr. Taberton was just demonstrating there.
I wanted to mainly point it out because sometimes it comes up open like that automatically and you want to get rid of the things.
Uh-huh.
But anyway.
Okay, well, thank you for that additional guidance. Now, one of the things that I think is really cool about ArcGIS Pro is that you can store the data in the project Geodatabase. Now, strictly speaking, for this exercise, we don't need to do this, but I think it's useful to establish sort of a standard of practice, like this is what you do when you do projects. And what I always do when I start off is I always show everything in the project database. It doesn't matter where it came from. So if we go to the evaporation data and just right click on this and say data export features. Now notice that a new tab is opened here now called geoprocessing, and this is for copying features. The input features are evap, which is the data set that I just evoked here, and this output feature class says evap copy features. But if you just click on that, you'll see that actually it's stored inside the X1 project Geodatabase, and I'm just going to call this evap again because that's what we want to call it in this context. And now I'm going to say run. You can't do anything in geoprocessing without run. It's easy to fill things out and then go, oh, what's going on? You know, nothing happened here. Well, that's because you didn't press run. Now you'll see that this new evap that appears looks just like the old one. So this is the one that was created from the shapefile. This is the one that's now in the Geodatabase. And we're going to take this one and say remove. And just get rid of it. So you can see there's no change in the map. But now if we go to the catalog and look on that, we say, oh, bingo, look at that. We've now got our evap data inside the project Geodatabase. And similarly, we can say Texas data export features, and again we're going to say just Texas here, not the copy features, and say run. And again the new Texas comes out looking like the old one, and we just say remove for the old one. So now we're not using the shapefile anymore for that. And similarly here for counties, we say data export features, and we can say counties and just get rid of the rest here. And say run, always say run. And now if we look at the catalog, you'll see counties, evap and Texas are sitting there. Okay, this is cool. We've got everything all nicely set up. And if we say project save, okay, everything's cool. So now our data are in the place that they should be, and they are and everything's saved. Okay, so we've got our data set up correctly. And if we go to the project Geodatabase and start looking, we can make a few queries here. So if we come here and just right click, we can look at properties. And when you look at properties, there's something about the source, and sometimes it's helpful to know, just where is that project data. You can look it up and say, oh, it's over here, ZX1 project, blah, 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 blah. An important thing is this thing that says spatial reference. If you click on spatial reference, you can see that there's almost nothing to be seen here. You can sort of drag down the box and bring this into a visual form. And this says GCS North America 1983. What does that mean? Geographic Coordinate System in the North American datum of 1983. Now, we're going to talk about geodesy and map projections next week, and we'll explain more about what this means. But there's a certain shape of the Earth called the GRS 1980 spheroid. So the Earth isn't actually a sphere, it's actually a slightly oblate spheroid. And this is called the Geodetic Reference System of 1980, which is a set of standard dimensions for the major axis of the Earth, which is the equatorial axis, and the minor axis of the Earth, which is the polar axis. And the polar axis is slightly less than the equatorial axis. And this defines the Earth on which these coordinates are determined. In other words, the latitude and longitude coordinates. There are other ways of doing this, and there's World Geodetic System and some others as well that we'll learn as we go along in the class. Now, your first point of query here is to start saying, oh, look at down the bottom here, I can see some coordinates as I drag around. Now, if you have this explore thing here, it opens a pan thing and you can drag around. You can also press down the shift and you'll see this little plus button open up and just drag a box, and we can go to South Texas, wonderful sunny South Texas, Rio Grande Valley. And if you come here and just locate the cursor near the bottom of South Texas, you'll see some coordinates there, 97.40 west and 25.84 north. And that's roughly the location of the southernmost part of Texas. Which is the north-south, well, which is the coordinate that tells you the up and down part here? Which of these two? Yeah, the north, and in this case, this is the longitude and this is the latitude. So this is like an XY coordinate system. Longitude is here first, and here's latitude. And this is west and this is north. So what I've asked you to do is to make a little, do a little exploring here, zoom out and zoom in and so on, explore around. And I've asked you to find the latitude of the most northern and southern locations in Texas and the longitude of the most western and eastern locations. And I've asked you what's the north-south extent in degrees of latitude and what's the east-west extent in degrees of longitude. So measured in decimal degrees, is Texas wider than it is taller, or the other way around? And the data that you're seeing here are in decimal degrees. So if you look down the bottom here, it's not degrees, minutes and seconds, it's decimal degrees. See, 97.469 or whatever. So you can actually take those numbers and manipulate them like they were regular decimal numbers. So you can take, okay, if I've got 25.83 north to 36.5 north, which you'll see is the latitude at the top of Texas, you can subtract one from the other and you get 10.67 as the north-south extent. So I'm asking you to do the same as this in the east-west extent and then make some assessment of, are we wider or are we taller? Now, as we go along in the class, you'll see that this question of what's wide and what's tall and in what coordinate system you're in is sort of a tricky thing. Later on in this exercise, we're going to use a projected coordinate system called the Texas-centric mapping system that is actually in meters and not in degrees. And then Texas goes, suddenly loses weight, becomes in. And so it becomes sort of a taller or thinner state just because we changed the projection. So the question of how wide things are and how tall things are is something that we're going to come back to a number of times in the class here. And this is just your first kind of dip into the pool. There's a number of different background maps that you can use, and in this exercise you'll see maps with both streets and topographic map on them. I really don't care which one that you use in the hard work exercise, so this is some place where you get to make a choice for yourself. If you want to use a different background map, that's fine. When we ask you to turn in a map, this is a point where you get to choose, what you want to do. You don't have to just follow blindly exactly what the script says. So if you want a different background map than the one that you see here. Now, if we wanted to zoom out to the rest of the state, if we just say Texas, right-click, and say zoom to layer, then bing, we're back at Texas again. You don't have to sort of back. If you do want to go back to where you were before, you've got this little thing that says previous extent. Oh, look at that. That's cool. In this case, I made a mistake. Then you can go previous extent. You can keep going back. But in this case, we're just going to say zoom to layer. Okay, so we're back here at the whole state, and let's say we want it. So here we've got the topographic map, and that's the one that opens by default. So if we wanted another one that said the street map, then okay, we can get some, and you can see a few roads here, which is sort of helpful. But since we've got the counties all coloured in, you can't really see very much. So what we're going to do is to make the counties as outlines as well, so that we can see inside and see the roads underneath and sort of zoom in. And we're going to zoom into Travis County, this den of liberalism and a nice conservative state.
What is there, one liberal there?
Yeah. We've got like 6 congressional districts in Travis County because to try to dilute the effect of the Democratic voters here. Lots of Republicans in other parts of Texas. What can you say? Is this a great country or what? Okay, so if we just click on counties, we can again say go to color and no color and say apply, and oops, we should Symbology counties apply. I didn't delete the old counties. That's a very interesting thing. Okay, so I forgot to delete the old counties. So what you see here is I actually reconfigured the old shapefile version of the counties and not the new one, the one that was in the Geodatabase. So let me do this again now on the one that's in the Geodatabase and say, okay, apply. Okay, there we go. That's good. So let's save that so that we can zoom in. So let's zoom in to Travis County here. Who's Travis County named after? Colonel William B. Travis, who was commander in the Alamo, 27 years old. Yes, the commander of the forces in the Alamo. The birth of the nation of Texas. So here we are in Travis County, and we've got the city of Austin in the middle here, and we've got a dot off to the left-hand side here, which happens to be a pan evaporation station, which is near Lake Travis. So if we zoom in near that station, you can see where it's located, and if we come in even closer, you can see it's actually located near a small bend in the outline of Lake Travis. Lake Travis is a flooded river valley. That's why it looks like this. got a big dam there. The dam is just located there. So we've got a site here, and we want to be able to label this. And we're going to use the properties of these data. And Dr. Tarberton says a good idea is to open up the attribute table first so you can see the properties, so I'll do that. So here's the things that we could use as labels, and we're going to use this one that says station here, like Armistead Dam, Bardwell Dam, and so on. And so if we go to evap and then say labeling properties, we're going to say feature station. It's already set up so that that will occur. And we're going to say symbol appearance 16 point. Now this gets pretty obscure once you start digging down this far. So let me just do that again. So if we want to say here, I want to have labeling properties. There's an uncommitted symbol formatting. Do you want to apply it? I'll say cancel. Okay. So labeling properties. You first have to make sure that this one is the right one that's selected. Let's just delete this and say, okay, I've got a number of things I could use. I could use longitude, number of years, or so on, but I'm going to use station. So you see feature.station is the expression that's used for creating labels. And then if I say symbol, no, I don't want to do that yet, symbol and 16 point. And so you've got to go to symbol appearance and then to be able to resize it and also recolor it if you want. And then if we say evap and then label, you'll see nice labels appear. So this labeling properties establishes what your labels are going to look like, and then the labeling action itself, which is a toggle that go on and off, gives you the label, turns them on and off in the map. And if you zoom back, you'll see other pan evaporation stations that are labelled nearby. But let's zoom in on this one a little bit more and say, gosh, if I really wanted to know where that thing is, I see it's next to a road there. But hey, if I take this base map and say, oh, I want imagery instead, oh, that's totally cool. Look at that. I can zoom in here and I can see, oh, yeah, it's right down by that dinky little road there. And now I can't see this label anymore. So if I go back to evap and change this color here to something light, let's call it, I'll do yellow here, and now you can have your labels yellow and you can see them against the imagery. But if you...
Do you think the pan is...
I'm
do you
sorry,
think the photo is good enough that if you turned the evaporation off and you zoomed in, you'd actually see the pan?
Well, that's a good question. I don't know if we are good enough for that.
It's getting fuzzy. It's kind of in the middle of a tree. The location may not be exact.
Yeah, maybe this is... Yeah, I don't know. The imagery is...
It's got it in the middle of a tree.
Yeah, it seems like it should be... Yeah, I guess this is the best we can... Well, it's near a tennis court. There you go.
Go a little bit further out, it'll be near a swimming pool too.
Yes. Well, there you go. There's a swimming pool, yeah. Okay, this is Texas. What can you say? You can go play tennis and look at a pan evaporation station. Okay, so let's just change this back now to black, because black will suit the normal background that we're going to use here. And I'll change the background map back to the roads map again. I think you can see how informative the aerial imagery is when you really, really get down close. When you're about at this level, you can see this roads and the sort of recognizable roads and names and things like that, but the imagery is the definitive statement. Okay, so we've got that far. What have we got to do now? We've put labels on things, we've zoomed in, we've seen some imagery. Okay, so let's just save our project. We've done what we needed to do there. We've now been able to see label data and see what they look like at close up. Let me just clean this off. You notice this as I zoom out. See, look at this. Says 1 to 29,878. That's the map scale. So this says 1 centimetre on the map is 29,878 centimetres on the map. If I just said oh gosh, I think I'd like a 1 to 50,000 scale map, it looks like that. If I wanted to have a 1 to 500,000 scale map, it looks like that. So this thing down the bottom is constantly telling you what is the ratio between the size of the Earth and the size of the globe, or the flattened globe that you're looking at here. Even a 1 to 1 million map would look like that for this area. Okay, so let's go back to our text and see where we are on page 32. So that's good, we're making good progress. Now we're going to talk about accessing and querying attribute data. Now there's a couple of different ways that you can query the data. The first is that you can just take your cursor from the Explorer here and put it over the top of a dot and say, hello, tell me about yourself. And when you do that, you get a series of attributes here, which are the values that are associated with that particular feature. And you can see that they go down, whoops, a little bit more space here to see everything. There we are. So now you can see that this is object ID 25. In ArcGIS, everything is automatically got an object ID. That's the way it keeps track of things. So don't worry about that. That's not something that you mess with. It has an attribute called station, which is the name of the station, which is Lake Travis. It has a latitude and longitude, which are just attribute values that are there for your information. They don't have anything to do with where it's actually being plotted on the map internal to the system. In this case, there are 8 years of data that were recorded from 2003 to 2010, and the average pan evaporation for the Januaries was 2.43 inches, for the Februaries was 2.73 inches, etc. And the total of those is the annual pan evaporation, which is 69 inches. So these are averaged data over a period of 8 years, and the different pan evaporation stations, they're over different periods of data. The data were compiled by the Texas Water Development Board to help with identifying how much evaporation happens off of lakes. So this is not evaporation from the ground surface, this is evaporation from an open water surface, and these stations are next to big lakes so that you can figure out the depletion that's just going straight up to the sky. And there's a discussion here about what an evaporation pan looks like. This is an evaporation pan. Who's worked with evaporation pans? No? Anybody's done evaporation pans? I used to do this stuff in one of my former lives. And what you do is you go out at like 9 o'clock in the morning, and they often have a hook gauge. I don't know how this one's measured, but you actually measure the surface elevation of the water. You bring the hook up until it just breaks the surface, and you have a rain gauge next to it which measures how much it's rained. So you take the difference in elevation of the water level in the pan from today versus yesterday, and you adjust it for how much rain occurred in between. And that's how you get an estimate of how much water just evaporated straight off the water surface that you see here. This pan is 4 feet in diameter, and it's made out of copper. It's a standard measurement device for measuring evaporation. Okay, so viewing an attribute table. So we've opened up the attribute table, and I showed that before. Let's open it up again. So evap, open up the attribute table. And let's zoom back a bit so that we can see what we're doing. And we're going to turn off the labels because it looks a bit junky. And we're going to search for Lake Travis. And I'm just going to cycle through this in a moment and just select one of the points here. This is the record for Lake Travis. And when I do that, you'll see that it shows up blue in the map, just as it was selected in the attribute table. So this is really the key thing that I was talking about last time, that GIS is a system that every feature has one record in a data table, and they're one-to-one associated with one another. So the pan evaporation for this particular station, the values that you saw in the pop-up are the ones that come in this attribute, this row in the attribute table. Now this is not Excel. This has nothing to do with Excel, actually. So you can see that these tables have names at the top. They have real descriptions. You can't just go right up to the top. This top layer has always got names in it. These data are filled out all the way down. So this is a square table. It's got values all the way down. These are dead data. There's no formulas here. There's no embedded formulas. There's no, A1 equals 2 plus 3 or something like that. So data tables as used in ArcGIS and used in database systems are not like Excel. There's no life here. These are dead data, and they're acted upon by external functions that produce more inactive data, you could say. There's no embedding of formulas with data in data tables for GIS. Now later on I'm going to show you how to export these data out to Excel so that you can do all the things that you normally do in Excel and do cool calculations, and of course then you can bring the data back if you want. But here you've got a table, but it's not like an Excel table. Okay, so if you want to select a number of features at a time, you can come to the map and say I want to select, and I want to select using a select by rectangle. So if I do that and just put a shift and then just drag across here, I've got several points are selected. I'm going to turn off the county so that doesn't get confusing. And you see there's 3 data stations selected. Down the bottom here there's a thing that's all the records, of which you can only see one here, which happens to be Buchanan Dam. And you can click on this one, which is the selected records, and here you've got Buchanan Dam, Lake Travis, and Wirtz Dam. So if we just label those again, just for the sake of seeing where they are. So if we zoom in a little bit, let me bring this down so it's easier to see. And so we've got, whoops, I managed to, yeah, if you've got the thing automatically set on select, you can't pan at the same time. So let me select again, and here's our 3 sites. So here's Buchanan Dam, Lake Travis, and Wirtz Dam. And they're in this particular order, which is the order that they're set up. So you can have multiple records selected in the map, and you can have multiple records selected here, and as you go along you'll do this a lot for selecting out particular sets of data that are within larger data sets. Okay, so where are we? Very good. So once we've done that, we can go up here and say clear, and then you can see this goes blank. The attribute table goes blank. So if you want to get the attributes back again, you have to click this one that says show all records, and then all your records come back again. So this one is selected records, which in this case when there's no selection is blank, and this one is all the records.
Now you might want to think remember when you did the selection, you also came up with counties being selected. There's a way that you can actually avoid that.
Okay,
if you go back to, so in the table of contents up at the top, go above where it says drawing order and pick the 3rd one over from the left.
This one.
That one.
List by selection, okay.
So click on that.
Okay.
Now you can choose which layers the selection is going to act on.
Okay, so if I turn off counties and turn off Texas and say select by rectangle. Ooh, cool. That's cool. Okay, there you go. I didn't know that. So that's good. That's a good tip. So these different symbols.
Another thing you'd also have to pay attention to here, those. If you end up in this mode now, suddenly you say you want to put Texas above counties and you try to drag it up, it's not going to work. So you're going to have to switch back to the...
Okay, so if we try to drag here, oh, it works.
That works, okay.
There we go. Normally,
sometimes,
we normally have to be in this order, this thing here, to make that work.
Fine.
Yeah, this one here, I think that's the content of the data.
That doesn't work.
Yeah, from the database. Is that right? Yeah. Anyway, let's just do it this way. So this is the normal one. The normal order is that one on the left here, which means you can drag the files around. Oh, that's odd. Anyway, let's come back here and just turn all these on again. Make sure I haven't messed up something. Layer properties, Texas. I don't know why that's...
Maybe because you're in select mode, rather get into the explore mode. at the top.
Nope. Oh, well, let me save my project and... Yeah. Anyway, it doesn't really matter. Yeah, that's one of the reasons why I don't do that. Sometimes you start when you start going places that you've never been before, you end up somewhere where you're not sure what you're doing. But anyway, what I do is just turn the themes off. Okay, so let's talk about mapping the annual evaporation. What we've got now is just a set of dots, but what we'd like to have is something that is more explicit in showing how much evaporation is recorded at each one. So let's zoom out to the extent of the state again. So zoom to layer. And now we're going to change these dots so that they represent the size of the object that we want to deal with. So actually in this case it's better to do it the way Dr. Tubbington suggested earlier, which is just right click and say Symbology. And instead of saying single symbol here, we're going to select graduated symbols. So those smaller symbols or bigger symbols according to whether there's more or less evaporation. Now here the attribute that's been selected is latitude. So as you go north, the dots get bigger, which kind of makes sense. But what we want to do instead is to select annual. And here you see there's some bigger dots over here and some smaller dots over there, so that seems like a kind of interesting pattern. Let's make these blue so that they stand out a bit better. Say apply. Okay, so we've got some sort of idea that we've got some smaller dots over here and some bigger dots over there, and maybe some, I don't know, it's a bit hard to tell whether they're going north to south, the dots get bigger or smaller. But this is a map now with a symbolized version of the information. So yeah, so we go from single symbol and we go to graduated symbols. That's what we've just done. And we use annual as the value that's being plotted. Graduated symbols, there's also graduated colors, which you can have the same size of symbol but different colors in them. But we're not going to use that here. And so here's the map, and I want to use topographic base map because I like that. So I'm going to go back to topographic base map, and there's our nice map now with pan evaporation for Texas on a topographic base map. Okay, so what have we got here? Making a chart. Okay, so you can see from this map that there's some tendency for the pan evaporation dots to be smaller on this side than they are on this side. So let's explore that a little bit. So we're going to say make a chart. So we're going to take the pan evaporation data and say create chart. Now you can see that there's lots of different charts that you can do here. I'm going to use this one that says scatter plot. And when you say scatter plot, this tab now, which is called a chart tab, opens up. Notice how there's the label tab that you use to do labels is still there. Geoprocessing tab is still there. Chart tab is now added. As you build up the project, the number of tabs that are retained on the bottom here starts to increase. So you don't have just the two that you started off with, as more appear. Now in this case, we've got the data tab. For the x-axis, we're going to put the latitude. And for the y-axis, we're going to put the annual evaporation. And so if you look at this, you look at that and you say latitude and annual evaporation. What do you learn out of that chart? There's no real relationship between annual evaporation and latitude. That's really kind of interesting, huh? You might think that, well, no, up in the high plains there, it's drier, you know, and down on the coast it's more humid or something. So you'd think somehow intuitively that somehow going north there should be more evaporation. But then perhaps it's hotter, you know, the sun's hotter down in the south. Anyway, the data tell you that there's really nothing there. So instead of having latitude...
It's interesting to do this for a bigger scale, because I think if you were looking at the continent, when you get up to Canada, the evaporation's got to be less.
Yes, that's true. That's true. So probably this is an interpretation that's sort of limited by the extent of the study. Let's put longitude here. Oh, look at that. Isn't that cool? So this is one of these things where the data start to tell you something. And the fact that we can do the charting inside of ArcMap or ArcGIS is actually kind of neat. So now we've got a nice little chart, and it's got a slope on it, and it's got a trend line in there. Actually, there's even an equation for the trend line. You can see it over here, and it's actually, I guess it pops up if you... Oh, look at that. Longitude, longitude,
So that's telling you the individual point values.
No, I don't think so. I think let's go out here somewhere.
Okay.
Oh, no, you're right. There's no values there.
So see if you can click on one of those points, and it'll tell you where it is on the map. I think you can do selection there.
Okay.
So if you were in where the outlier is, for example.
Okay, so let's look at an outlier. So that one there, for example, that looks kind of weird. So if
there's a selection, go to the selection up at the top, or I guess at the top of the chart.
Chart.
There's a selection.
Oh.
No, at the top of the chart, lower down. Just at the top of the chart, not at the top of the. Above there, it says selection.
Selection here, filter by selection. No, not what I want to do. Let's go back to the map and do it that way. So let's say select here. Let's select by rectangle. So let's suppose we just say, okay, I want to select this, and there's that point. Oh, look, here's this point, and that's that one over there. And so you can see, so there's this point over here. Maybe it's in Louisiana. You can see this point that's right on the border on the Sabine River between Texas and Louisiana. Well, what can you say? You know, they're really interesting over there in Louisiana. You've got these three other smaller points here, so let's just check them. And again, let me turn off the counties just to avoid confusion. So you can see here's 3 points. I'll turn off. Well, I'm going to turn off Texas. So here's 3 points here, and you can see here's these corresponding 3 data points on the chart. So this is kind of a neat thing. Just the same as you've got dynamic connection between the map and the table, you've also got dynamic connection between the map and the chart, and also between the table and the chart. This is called painting. And it's really a nice exploratory tool in ArcGIS that you can start to think about, oh, okay, well, let me think about that. Why is that like that, and so on. And you can sort of switch around and make queries. For example, what about this one over here? I think that's this one here, which is the having these blue isn't very helpful because the selections color is blue, but that's actually the evaporation near El Paso. Okay, so I've made a chart here, and you can see that. Oh, let me finish the chart first. So we've got the chart here. We've got this relationship between longitude and annual. That's kind of not very helpful. So let's go to general, and it says relationship between longitude and annual. Let's replace that with pan evaporation in Texas. And instead of having annual, let's say annual evaporation in inches. This is actually easier to manipulate the scale labeling and so on than it is in Excel. In Excel, you really got to know, how to hold your mouse right to be able to change the axes. There is a way of doing it, but you've got to really know what you're doing. So annual evaporation in inches, pan evaporation in Texas. This is just longitude. Oh, that looks okay. You can see 50, 60, 70, 80, 90 inches. Let's clear all these selections so that we don't mess anything up. So now we've got a chart. We've got a map. Those two things look like they're informative things that we'd like to record some things about them. And if you look at the chart tab over here, chart properties, go back to data, you'll see that there's the equation. See, it says y equals minus 311.344 plus, and then it says minus 4.02294. That's a bit of a not very good software there. That should actually just say minus. So, so really what's going on here is that you can say, I can calculate the evaporation at any longitude as minus 311.34 minus 4.02294, and then you put in the longitude, but you have to put a negative sign in front because that signals that it's west. So this is longitudes inside the computer are always negative. So if you plug all those things in, you'll get a number. So I put in 98 degrees west because that's near Austin. And what I've asked you to do is to use the values of the longitude for the western and easternmost locations in Texas to make an estimate of the pan evaporation at those locations. By how much does the expected pan evaporation increase as you go from east to west, and why is this so? So just a little bit of an interpretation here of what the data are from this equation. Notice you've got to sort of extrapolate a little bit because, well, these points are actually at the easternmost point and this is not quite at the west, but there's some smoothing of the data going on there. Okay, so that's your second to be turned in piece here. There's some other charts here, histograms and other things that you can do. So you can, let's save the project so we don't lose our chart if we have a blue screen of death here. And if you want to export the chart, you can say export to an image file, and there's different image files that you can use here, so you can actually just keep the chart as an extra item if you want. So let's see what else we can do with charting. So if we come here, create a chart, if we're going to create a histogram, let's create a histogram. Select the variables to be in the chart, so let's go with longitude and annual again. Oops, no transformation.
The histogram is just a one variable
thank
chart.
you. Thank you, Dr. Tarleton. Just a one variable thing, just with annual. So this is the histogram of the annual evaporation. So you can see it's roughly symmetric. I guess you could probably a few more points in the center over here than you'd expect. Some other things here are, there's a box plot. Oh, let's look at box plot. That's usually kind of cool. So let's see, fields. Let's just say annual again. So this is the distribution of annual evaporation. Why don't we just take, for example, January. Oh, there's the variation for January. And let's take out annual and put in July. All right. Let's put in July. Yeah, so here's the variation.
So unclick the standardized values because it's showing a z-score if you want to see the difference between January and July.
Well, there you go. Thank you. Huh, that's interesting. Okay, so this is just the raw values here. So here's the pan evaporation in January. Here's the pan evaporation in July. Later on, I ask you to make a little chart of January through December evaporations and compare the average of the minimum month to the maximum month to find out, how much are our reservoirs getting emptied out in the hotter months compared with the cooler months. And you can use something like that. But anyway, here's a little mechanism for doing box plots. Now, what Dr. Tarleton was...
You could actually do it for all the months over here if you wanted.
Okay, well...
You could add additional months.
Time, no, we've only got 15 minutes left, so let's continue on here. So, yeah, I won't, so z-scores means the values have been taken and their mean has been subtracted and the standard deviation has been divided. That's why it goes from 0 everywhere. And so this actually shows that relative to its mean, the January evaporations are more variable than the July ones are. Okay, so now you've got a series of charts here that you can see, evaporation, distribution, evaporation, etc. The one that we're interested in really to keeping is that one. So I'm just going to turn these other two off for the moment. And if you want to get your charts back, you click this item here and it lists the charts that you've got. So you can get them back and you can identify them and start working with them again. Okay, so let's go back to our item. We've got charting in Excel. Now to chart the data in Excel, what we need to do is to take the evaporation data and say data export table. And we're going to, whoops, no, we don't want to do copy features. We want to use the geoprocessing here. And in geoprocessing, we're going to find a tool which is called Table to Excel. Table to Excel. And here's Table to Excel. And the input table is going to be evap and the output Excel file is just going to be ex1 something something, and so I'll say run, and then if I come to over here to where we've got our data, suddenly we've got this evap table to Excel thing, and if I open that up, I'm going to find all the data in Excel. So this is a very nice clean connection here between Excel and ArcGIS Pro. So here's all the data, and I've asked you to make a little pie chart for one of the evaporation stations of what the evaporation variation is over the year. Now making a map layout is the next thing that we're going to do. So if we come here, we're going to say, okay, so let's save our project, make sure we know what we're doing. And now we're going to, you have a question? Yes? Yes, what's the question?
Can you please explain the process of getting Excel sheet again?
Okay, so if we go to evap and say I'm going to use geoprocessing, there's a function in geoprocessing called table to Excel. So if I come here and say, and I'm just searching amongst all the functions, these are all tools that I could have accessed through the geoprocessing toolbox. I just happen to know that there's one called table to Excel. If I just start typing that, so I'll just start, for example, I start off like this, so I just start typing table. You can see already it's starting to filter out, right? This is an auto-complete thing. I don't even have to go any further, I can just stop here. Table to Excel, I just put in the name of the feature class whose table I want to export, and automatically it comes up with an Excel file which is called evap underscore table to Excel underscore 1.xls. Now you could change this and you could say, I don't want to have all this other junk here. I just want to say evap table or something like that. And then I could say run, and if I do that and come back here, I now got two Excel files. This one called evap table. Now there's an equivalent function called Excel to table, which does the reverse, right? I've got an Excel spreadsheet and I want to make a table out of that. So the same thing happens in reverse. If I went back here and said Excel to table, you put the Excel file in here and a table comes out, and that way you can put the data back into the Geodatabase. Okay, so let's go back to where we were. We're going to make a layout. So let's come back to our little map here. We're going to say, first of all, we're going to insert a new layout. So if we come back here to ArcMap and make this a bit smaller so it doesn't take up so much space. So now if we go to insert and say new layout, and we're going to use the letter size layout. So now we've got oops, let me go back to my script here. And so we want to go on ArcMap to the layout tool, and
you might want to make it bigger. There you go.
Yeah, so now when you do that, you suddenly find, whoops, this is really tiny. Let's see, I figured this, there we go. Layout, zoom to page. There we go. Yeah, I went through this when I was preparing the exercise. Okay, so now we've got to this point, and we want to add our map to the layout. So we're going to add a map frame. This is called map frame here. So layout, insert, layout, insert map frame. Let me just check my cheat sheet.
Here.
Insert map frame. That should be there. Insert map frame. There we go. And you do it on this right-hand side one. And see, you can see it's a big box, and now the map of Texas comes out kind of scrunched up in the middle. So if you just bring this up like this, then you've got about half the page taking up the map, which is sort of what we want. So okay, now we've got a map in our layout. We also want to be able to, there's a series of notes here about how to get your map centered if you want to do that. So if you come here and say layout and then activate, you can actually drag the map around inside and you can zoom in and out. You can actually change the location of the map inside your display here. So let's see, map. I'll turn off the layout.
Click on the, where it says layout at the top, just below.
Thank you.
At the top of the layout pane.
Yeah, close activation.
Okay, that'll
there we
work.
go. So close activation. Okay, so now we want to add a chart. So coming back here, we want to add a insert. Oops, add a chart frame. So the same kind of idea as before. So I want to insert this one. And here's this will show up in a minute. So now I've got the chart down the bottom here. And you can see it rescales to the correct size. There's also insert a north arrow. So we go like that and say, whoops, here's my north arrow. And I'm also going to insert a scale bar. Well, I'll leave that where it is. And insert a scale bar. And we'll put a scale bar here in miles. Now, Dr. Tarberton has spent quite a bit of time in the exercise explaining why when you're using decimal degrees, it's not strictly correct to put scales in miles, and there's a section of the exercise that involves reprojecting the display so that it's in a projected coordinate system, which, in the interest of time, I'm going to skip over. So I'm going to skip over this, some of the details here. So now I've got a map which has got, it's got a scale bar and it's got a chart in it. So let's put my name at the top because, gosh, we wouldn't want to miss out on that. So you just click on text and come over here and click on something, and you can see it's really kind of dinky. So if you just say pan evaporation in Texas, and then click on this and sort of do it the right way, it'll eventually work. There we are. And you can make it bigger. So there we are. And you can put your name and other kind of things on that. So eventually, once you've done that, you end up with a map which has got David Maidment, whatever it is. You put your name on here and you have a nice map and a scale and everything's hunky-dory. So with that, you can then say, I've got my layout finished, save, and I'm going to layout, go to share, I'm going to take my layout, I'm going to export it. I could do it as a PDF file. Another way to do it is just export as a TIFF. And if you export as a TIFF, then your layer is just one graphic element, and you can take a Word file and you can go to where you were at CX1. Oops, I'm not sure where that file went to. I guess it's up here. Yeah, I've got a version of it here. So we can just take Word and you can say insert picture and then go to the location. And it's there. Insert. And you can just insert it as a graphic directly in a Word document. And that way you get a nice map and you don't lose any quality and so on. You don't have to do screen captures or anything. It gives you a really nice cartographic quality product. Okay, so that's the finish of the preparing a layout, and the last thing that is in this exercise is how to share it as in ArcGIS Online. If we come here, come back to layout, and so we want to now take this, and we're just going to look at the map rather than the whole layout. So if we come back to the map view, how do I do that?
So you just click on the map tab at the lower down where you've got
There,
your
okay, map tab. Okay, here we are.
yeah. Or maybe close the layout one.
Yeah, that's a good idea. Let me just put it down here. Okay, so here's our map. And if I want to share that into ArcGIS Online, I can then say, okay, I want to create a web map. And let's see, let's create a web map.
Under share,
Thank you.
top menu.
Share, thank you. That makes sense, create a web map. So when you're doing that, you create something here, let's call it evap class. And you put a summary. Hi, how are you? And some tags here like evaporation and blah, 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 blah. And then you can say analyze. And when you do that, you're going to say, oh, the service layer has a different projection. Now, this is where we run into a problem, and that's because all these background maps are in a special projection that was worked out by Google. And so you have to put all the maps in the same projection as that. So if you take your map and then say, I want to have properties, coordinate systems, I want to have the coordinate system set as Web Mercator auxiliary sphere, okay. And now if we analyze again, that warning's gone away. And now we can say share. Now, I'm a bit concerned because of time. If I do this, it's going to takes a while, but so what's happening here is that it's going to share the map out to the web. In the interest of time, I'm going to just go to the web and show you what that looks like. So you come to www.arcgis.com. So now you're on the online system, not on the desktop system anymore. You sign in as yourself, like you do at the web system. Maintenance.